All right, let's jump into the Calvin cycle. Okay, and again, the Calvin cycle going to be the light independent reactions. Okay, that means that they do depend on light because they depend on the products of the light dependent reactions. Okay, but they don't really require light directly. What is the big point? What is the big point of the Calvin cycle or the light independent reactions? Well, kind of you know this, you know, kind of the whole gist of it. Produces glucose from carbon dioxide. So yes, carbon dioxide is not going to be used here. Remember, we didn't use carbon dioxide for anything in the light dependent reactions, but we use them in the light independent reactions. Why do we use carbon dioxide? To make glucose, going from look a little bit weird, it's a little too complex. I just want you to know the major steps. So just follow me and you'll see what you need to know about this. So during each turn, around three, and turn because it's going to be a cycle, okay? Three carbon dioxide molecules are going to be incorporated to make a larger molecule, okay, called G3P. So carbon dioxide and ATP and NADPH are going to be used to make a sugar. But this is the thing. I've been saying we're going to be making glucose. In reality, what happens is after one cycle, after three carbon dioxides go in, we don't end up making glucose. We make up something called G3P, which is glyceraldehyde 3 phosphate. Technically, this is the final product of the Calvin cycle, okay, at least of three carbon dioxides. So what happens? How come I keep telling you we are making glucose? Well, because technically we need two of these, okay, we need two of these to make glucose, which is going to happen later on. Okay? But really, in reality, you end up getting G3P. Okay, so it takes two turns of the Calvin cycle to produce one molecule of glucose. Why two? Because you need to make two of these. Okay, you have to make two G3Ps to make a glucose molecule. Okay, G3P is going to be a 3 carbon molecule. Glucose is going to be a 6 carbon molecule. Okay, now this is a cycle. And yeah, it's going to get a little crazy. So please follow up with me. Okay, take it slow. Pause me if you need to. So first of all, the Calvin cycle occurs in the stroma. Okay, and be careful, guys, because I'm gonna try to trick you. Okay, the stroma is not the same thing as stoma. We talked about this before. Stoma is not the same as stroma. Okay, stoma is the pore, the opening, the leaf to allow for carbon dioxide to go in and oxygen to leave the leaf. Stroma is inside of the chloroplast, and the stroma is where we see this Calvin cycle. What goes in to the cycle? Three carbon dioxides. Remember, this is going to be our source of carbon. Okay, 9 ATPs, energy, and 6 NADPH, electrons. Really, that's what we care about is NADPH. That has the high energy electrons. That's what goes in. Now, what goes out? Well, a product, G3P, right? Which if you two G3Ps makes glucose. Now, we no longer end up with ATP, we end up with ADP, okay, which is going to go back to get phosphorylated to make more ATP, and 6 NADPs plus, they're going to go out and going to get more electrons to get reduced, okay? Okay, now let's look at this and take it slowly. Okay, let's look at my picture here. First of all, the Calvin cycle has kind of three phases. Phase one is called carbon fixation. What is carbon fixation? Adding carbon dioxide to an organic molecule. That's really what it is. Adding carbon dioxide, adding an inorganic carbon into an organic molecule. Okay, that's what happens in the first phase. We're adding carbon dioxide to a bigger organic molecule. Now, another thing you need to know about this is this. What makes it happen? Rubisco. Rubisco is an enzyme. And what is the importance of this enzyme? Is that it is said to be that enzyme, that Rubisco is the most abundant enzyme on Earth. Okay, so the most amazing, most amazing, well, I don't know if amazing, but the most abundant enzyme in the on Earth. Okay, and Rubisco, what is Rubisco going to do? Well, Rubisco is what's going to lead, okay, this carbon fixation. Okay, Rubisco is going to catalyze carbon fixation. So it's going to add a carbon dioxide into an organic molecule. Okay. The second phase is reduction, and you know what reduction is now, right? We're going to be, if I say I'm going to be reducing a molecule, that means we're going to be adding electrons. In this case, remember those electrons from NADPH, they're going to be donated. Okay, they're going to be given up. We're going to be reducing another molecule. Okay, so that's what reduction means. Finally, phase 3, okay, is going to be regeneration of RUBP. RUBP is this organic molecule that we're talking about here. This RUBP is going to, or carbon dioxide is going to be added to this RUBP molecule. But this RUBP molecule, as you'll see, has to be regenerated because it's not regenerated. So we have to make it up again. Why does that make sense? Well, can we go through a cycle without this? No, we cannot. So in order for this cycle to keep going, in order to be able to put a carbon dioxide and make glucose, we need to have RUBP available. No RUBP available, no cycle, no sugar, okay, no glucose. Does that make sense, everybody? I hope it does. Otherwise, pause it. Okay, I'm gonna erase this, pause it anyway. Make sure you copy this because I'm gonna review this in a different way now. Okay, so pause it right now. So we're going to pause it. Okay. Now this is going to get a little bit confusing, but again, keep up with the main things. Don't go into the little details. I'm not going to ask you in the test something about details. I'm going to ask you about the big things. I'm going to ask you about Rubisco. What is Rubisco going to do? It's going to catalyze carbon fixation, right? What is carbon fixation? Adding carbon dioxide to a molecule of RUBP, adding carbon dioxide, inorganic carbon, into an organic carbon molecule called RUBP, right? Then we're going to be using ATP for energize this process. We're going to use NADPH, okay, to bring the high energy electrons and donate them, okay, and give them away in this process, okay, to make J3P. And then we're going to be using more ATP to regenerate RUBP, which RUBP is very necessary to keep the cycle going, okay? So what do we go in? 3 carbon dioxide molecules, and that's here. Now this could be a little confusing. This is where it gets really confusing, guys, because we have to keep up with the math. But don't worry, don't keep up with the math. I want you to keep up with the math right now, but I'm not going to ask you any math related questions in the test. Now, what am I talking about this? Why so much math? Well, here they say input 3 molecules of carbon dioxide, but they only show you one little circle, so 1 carbon. And this is just for simplicity. So what happens is this carbon dioxide molecule, like we said, carbon fixation, is going to be added to this molecule of RUBP. So I don't know if you noticed, but RUBP has 1, 2, 3, 4, 5 carbons. What happens if you add another carbon from here? Well, now you have a carbon molecule made of 1, 2, 3, 4, 5, and 6. Now you have a 6 carbon molecule. Does that make sense? Okay, so carbon dioxide is added to RUBP. RUBP is 5 carbon molecule. Carbon dioxide is 1 carbon molecule. You put them together, you end up with 6 carbon molecules. Okay, but then something funky happens here. This molecule is too unstable. So what's going to happen, I'm going to do this with a different color really quick. It's going to break apart. It's going to break apart. So we end up with technically 2 molecules of 3-phosphoglycerate for every 1 carbon dioxide and 1 IUPP, right? But then you see here 6. Now this gets really confusing. Well, because technically you have 6, right? 6 of these, because if you have 3 of these over here, remember you start with 3 carbon dioxides and 3 IUPPs, right? And you end up with 6 of this. Okay, you end up with 3 of this. Well, if they break apart, then we end up with 6 3-carbon molecules. Okay, but again, that's not really the important thing. The important thing is that you understand where everything comes in and what goes in and what goes out. Okay, I'm just giving you the details just to give you more context on this. Okay, so now we have this 3-phosphoglycerate, which we have 6 of those. So what's going to happen? Well, first thing that we need is going to be some energy, right? And this ATP molecule comes from the light. It comes from the light-dependent reactions, right? And it's going to be used for phosphorylating, okay? For energizing, but also it's going to be phosphorylating. What does that mean? Well, look at this over here. You have 1 carbon, another carbon, another carbon. You have a phosphate group. Once it gets phosphorylated, now you have 1,3-biphosphoglycerate. Okay. Now you have these 1, 2, 3 carbons, 1 phosphate, and another one here. Okay. Now it's energized. Now, what is coming up next? NADPH. And NADPH brings up what? The electrons. We're starting reducing these molecules, okay, giving up electrons, okay, and we end up with something called G3P, okay, and instead we end up with 6 molecules of G3P, okay, it's 6 here because we have 6 here. Does that make sense? Now NADPH gives up its electrons, it gets oxidized, right? So let me see, when you see NADPH is reduced form, but when it gives out its electrons, it becomes oxidized because it donated its electrons, right? And some phosphates comes out too. And then we get G3P, 6 G3Ps, okay? Now 6 G3Ps, and again, why 6? Because we started with 3 technically, right? It says 3. So we end up with 3 G3Ps. We started with 3 carbon dioxides and 3 of these, okay? And even though the picture only shows you 1, think of it as 6 over here, okay? So think of it 3 here and 3 here and 6 over here. Now, only one of these G3Ps, okay, is going to be an output. That's all you make. Out of all of this work, okay, you only get 1 G3P out of here. And then that G3P, like I said here, the output, right? G3P is going to be used for what? To make glucose or other organic compounds, other kind of sugars, okay? And what happens to the other 5 G3P molecules? Well, they're needed because we need to do what? We need to regenerate RUBP. So we're using this G3P molecule. We're going to go through a bunch of series of reactions. We're going to be using ATP again. And at the end, we end up with RUBP once more. How many? 3 molecules of RUBP. But you see how we have to regenerate? We start with a 3-carbon molecule and we end up with a 5-carbon molecule. So we have to put a lot of work into the system to be able to regenerate RUBP. Without RUBP, you cannot go through the Calvin cycle. Okay? All right, so that's pretty much it. So let me do this with a different with my little arrow. So one more time, let's summarize all of this mess over here. Carbon fixation, so Rubisco adds carbon dioxide to a 5-carbon sugar called RUBP. That's what happens in carbon fixation. Carbon dioxide is added to RUBP. Okay? Then we have to use energy from ATP and NADPH to produce produced by the light reactions. Okay, ADPH, ATP, and enzymes convert each 3-carbon molecule to a 3-carbon molecule called G3P. And 1 G3P is going to exit. Okay, so for every 3 molecules of carbon dioxide, okay, the net output is going to be 1 G3P molecule. Okay. And this G3P molecule is going to be able to go out and make glucose or other organic compounds. And then we have to regenerate G3P back into RUBP so keep going. So we're using energy from ATP enzymes to rearrange the remaining G3P molecules to make sugars to make the sugar RUBP. Okay, and 50% of the organic material used as fuel for cellular plants and respiration in plants. Okay, so 50% of this stuff, glucose that is made, is going to be used by these plants, and the rest is going to be used for all of us. And that, ladies and gentlemen, that is the carbon cycle. Again, don't get too. I gave you a lot of context here, but remember the big points. What is carbon dioxide? What is Rubisco? What does reduction mean? Okay, what elements do we need? What goes in? What goes out? Kind of that's the most important part, right? Also understand that it is a cycle. Okay, so you have to regenerate this RUBP, otherwise the cycle cannot keep going. Okay, and that's it with the carbon cycle.